In this video, I will walk you through free response question number 3 from the 2000 AP Calculus exam. Problem number 3. The figure above shows the graph of f prime, the derivative of function f, for the interval from -7 to +7. The graph of f prime has horizontal tangent lines at x equals -3, x equals 2, and x equals 5, and a vertical tangent at x equals 3. Part A. Find all values of x between -7 and +7 at which f attains a relative minimum. Justify your answer. Here are some notes that you will need to solve this problem. This is not something that you would need to write as part of your solution on the AP exam. A relative minimum can only occur at a critical value where f prime is equal to 0 or f prime is undefined. We are looking at the graph of f prime, so it will be easy to see where f prime is equal to 0. It's equal to 0 here at x equals -5, and here at x equals -1, and here at x equals 5. Here are some more notes that you need to know. According to the first derivative test, f of x will have a relative max at critical value x equals c if f prime goes from positive to negative. This makes sense because if the derivative is positive, that means the original function is increasing. And if the derivative is negative, it means f of x is decreasing. So it makes sense that we would have a relative max at the top of this hill. Similarly, f of x will have a relative min at x equals c if f prime changes from negative to positive. Again, this makes sense because if the first derivative is negative, it means the original function is decreasing in that interval. And if the derivative is positive, the function f of x is increasing. So it makes sense that we would have a relative min at the bottom of this little valley. Take a look at critical value -5. Notice that f prime is above the x-axis to the left and below the x-axis to the right. So f prime changes from positive to negative at x equals -5. According to the first derivative test, that means we have a relative max at x equals -5. And one more time, that's because the original function is increasing when the derivative is positive and decreasing when it is negative. Thus, relative max is here. Take a look at the critical number -1. Notice that f prime changes from negative to positive at x equals -1. That means we have a relative min at x equals -1 according to the first derivative test. And then looking at the critical value of 5, the derivative goes from positive to positive. That means we have neither a relative max nor a relative min at x equals 5. It's probably a point of inflection like this. So here comes the summary statement with justification. F of x has a relative min at x equals -1 because f prime changes from negative to positive. And that is your first derivative test. Part B. Find all values of x between -7 and +7 at which f attains a relative maximum. Justify your answer. Well, we already figured this out as we worked on Part A. We know there is a relative max at x equals -5 because f prime goes from positive to negative. And again, that is the first derivative test. So this would be your answer to Part B. That was pretty easy. Part C. Find all values of x between -7 and +7 at which f double prime is negative. A long time ago, we learned the graphical relationships between f, f prime, and f double prime. So we know that f double prime will be negative when f prime is decreasing. Notice that f prime is decreasing in the blue intervals and increasing in the yellow intervals. So that means that f double prime is going to be negative in these intervals and positive in these intervals. We are being asked where f double prime is less than 0. So that'll be from -7 to -3 and from 2 to 5. Wait a minute, not so fast with that interval from 2 to 5. You see, we have a vertical tangent line at x equals 3. That means the derivative of this graph will be undefined right here. And f double prime is the derivative of f prime. So f double prime will not be defined at x equals 3. So when we report our intervals, we will have to split this one up and say from 2 to 3 and from 3 to 5. So f double prime is negative for the intervals -7 to -3, 2 to 3, and 3 to 5 because f prime is decreasing and f double prime is defined. Notice I had to add in this last little statement to explain why we are leaving out the value of x equals 3. Part D is not so straightforward, so bear with me. At what value of x on the closed interval from -7 to +7 does f attain its absolute maximum? Justify your answer. Don't forget that in Part B, we found that f of x has its only relative maximum at x equals -5. Since this is the only relative maximum, the only other candidates for absolute maximum are the endpoints, -7 and +7. Here's the key concept that we will need in order to solve this part of the problem. The area under f prime is the change in f of x. So what do I mean by that? This yellow area is the area under the curve between -7 and -5. This area indicates the net change of the original function f of x from -7 to -5. An area that is above the x-axis represents a positive change in f of x. In other words, f of x is increasing between -7 and -5. That tells us that the value of the function at -5 is going to be greater than the value of the function at -7. Think about it. Let's imagine that this dot represents the value of the original function at -7. And then we have this positive change in f of x, represented by this positive area. So if there's a positive change, that means that f of x will increase from -7 to -5. So that means that the value of the function at -5 is going to be greater than the value of the function at -7. So we can rule out -7 as a candidate. There's no way to say this really succinctly, so let's just write up what we have so far. The candidates for the x value of the absolute maximum are x equals -7, x equals -5, and x equals 7. F of -5 is greater than f of -7 because f of x is increasing from -7 to -5 as shown by the positive area under the f prime curve. So now we are down to the last two candidates for the location of the absolute maximum, -5 and +7. We have to figure out if f of x is greater at -5 or will it be greater at 7. Let's again analyze the area under the curve of f prime. When I say the area under the curve, I really mean the area between the curve and the x-axis. So this blue area under the curve represents the change in f between -5 and -1. Because this is below the x-axis, this is a negative change in the value of function f. So imagine that this point right here represents the value of the function at -5. By the time we get to -1, the value of the function will have decreased, because that's what a negative area under the curve tells us. So f at -1 is going to be less than f at -5. What happens between -1 and +7? First, let's consider what happens to the value of the function from -1 to 5. We have this positive area under the curve, so that means that f of x will be increasing from -1 to 5. So we know that f at 5 will be greater than f at -1. But do we really know that f at 5 will be greater than f at -5 the way I have it drawn? Actually, we do. You see, this negative area under the curve tells us how much f of x decreases from -5 to -1. The positive area under the curve tells us how much f of x increases from -1 to 5. Because the magnitude of the negative area is smaller than the magnitude of the positive area, we have a net increase in f of x from -5 to +5. From 5 to 7, there is another positive area under the f prime curve. That tells us that f of x will continue to increase from 5 to 7. So f at 7 will be greater than f at 5 and f at -5. Picking up here at the purple part, f at 7 is greater than f at -5 because f of x has a net increase from -5 to 7, as shown by the net positive area under the f prime curve. Therefore, f of x has an absolute max at x equals 7.